Hello everybody, this is Mr. Yen, and in this video we are going to take a look at, this is lesson 7.6b, and I'm going to get you started on problem number 3 from that lesson. Let's take a look by analyzing the given information. We know that quadrilateral ABCD is a square. So definition of a square is 4 congruent sides and 4 right angles. So I can start by marking all 4 sides of the square as congruent. Another piece of given information is that the diagonal DB bisects ADC. So the diagonal DB, that's this diagonal here, that bisects the angle ADC. So remember, bisect means to split in half, to split into 2 congruent halves. So if that's the case, I know that this half, this angle ADM, has to be congruent to this half right here, angle CDM. Okay, so this is what I can mark just based off of the given information. And I'm being asked to prove that the diagonals AC and DB are perpendicular to each other. So I'm trying to prove that diagonal DB and diagonal AC are perpendicular to each other, like that. That's what I'm trying to prove. Okay, so I'm going to erase that for now so we don't get confused with the given information, but that's what we're trying to prove. If diagonals AC and DB are perpendicular to each other, what has to be true about angle AMD and angle CMD? Angle AMD, that's this angle right here, A to M to D, this one. And angle CMD, C to M to D, that's this angle right here. Well, we know from our notes from the first part of this lesson on page 1 that perpendicular lines form 4 congruent angles. If these 2 lines are perpendicular to each other, all of these angles that they form are going to be congruent to each other. They're all going to be right 90-degree angles. So that means if these 2 diagonals are perpendicular to each other, then angle AMD has to be congruent to angle CMD. This is really important to keep in mind because now this statement right here, if we can prove this, then we can prove what we wanted to prove up here. And actually at this point, if I've already answered this question, I have enough information to fill out my conclusion at the bottom. For my conclusion, I know that this is what I want to prove. Diagonals AC and DB are perpendicular to each other. So I can fill that in already, even before I've done any proof, because I know that's what I'm trying to prove. So therefore, AC and DB are perpendicular. And because, right, how do I know that these are perpendicular? Well, I've already said it right here. This is what I need to be able to prove so that I can prove that they're perpendicular. So I can fill that in too. AC and DB are perpendicular because angle AMD is going to be congruent to angle CMD. This is the conclusion that I want to get to. Now what we're going to do is figure out how to fill out the rest of this flowchart so that we can get to this conclusion down here. Okay. So then now it's asking me, how can you use congruent triangles to prove the statement from part A, this statement right here? How can I use congruent triangles to prove the angle AMD is congruent to angle CMD? Well, let's take a look at the diagram. Angle AMD is part of this triangle. Angle CMD is part of this triangle. So if I can prove that this triangle on the left is congruent to this triangle on the bottom, then I can prove that those two angles, AMD and CMD, have to be congruent because the corresponding parts of congruent triangles are congruent. So these two triangles here, the left one and the bottom one, are now going to become our focus triangles. So we only need to focus on the parts and the angles and the sides of those two triangles. And what I'm actually going to do is I'm going to erase some of my other markings to help us just focus on these two focus triangles. I'm going to erase some of this too, so that we can just focus on the given information that we have. Okay. So we know we want to prove that triangle AMD, that's the triangle on the left, is congruent to triangle CMD, because we know if those two triangles are congruent, then angle AMD is going to be congruent to angle CMD. Because we know that this is what we need to get to so that we can prove this. Okay, next step. List the three congruences from our given information. Based off of what we have marked, we knew that this was a square. So we know that side AD is going to be congruent to side CD. We were given this piece of information here, that diagonal DP bisects angle ADC. So that told us this right here, this marking in green. So we know that angle ADM is congruent to angle CDM. Notice between our two focus triangles, they share this side. They share the side DM, and any side is always congruent to itself. So I can also say that DM is congruent to DM. And then notice, okay, we had a side, we had an angle, and then we had another side shared between those two triangles. And notice how the angle that was congruent is touching the two sides. It's in between the two sides in these triangles. So that's why we have two sides and included angle this time, because the angle is in between and touching the two sides. And included angle the shorthand for that is side, angle, side, or SAS. And that's how we can say that triangle AMD is congruent to triangle CMD. Right, that's what we stated we wanted to prove up here. And we did that. Okay. And then from here, you just have to list the remaining congruent parts of these two focus triangles. So we've already listed 2 sides and 1 angle between those 2 triangles. So for the remaining congruent parts, that's when you're going to be listing like this side and this angle and this angle. Right, these are your remaining congruent parts, the parts that we haven't already mentioned up here. That's what that means. Okay. So now that I've hopefully clarified a couple of things and gotten you started on this, I'm gonna have you finish the rest of that. And you're gonna complete and fix anything that you did from this lesson and then resubmit for full credit. Thank you very much. And I will say goodbye and good luck.